You ever just look at your computer and wonder how it's even possible? You've got music streaming, a dozen browser tabs open, and a notification just popped up, all at the same time, and everything just works. It seriously feels like magic, right? Well, it's not magic, but it is an incredible feat of management that's happening thousands of times every single second.
So that's the big question, isn't it? How does it pull it off? How can one machine, with basically one central brain, create this seamless illusion of doing everything at once? That's exactly the puzzle we're going to solve today. And to do it, we're going to take a peek inside the busiest, most chaotic kitchen you can possibly imagine.
All right, here's the game plan. First, we're going to meet the cooks in this kitchen. They're called processes. Then we'll see how they're born and what they do. We'll tackle the huge multitasking challenge, meet the management team that keeps it all from falling apart, look at the rules they play by, and then, finally, we'll see why this whole invisible dance is the secret sauce to how you use your computer every day.
Okay, so let's set the scene. Imagine your computer's operating system, your Windows, your Mac OS, is the general manager of a massive, high-speed restaurant. Every single app you run, whether it's your web browser or your music player, is basically a cook in this kitchen, and each one is working on a specific dish. Now, in the tech world, each of these cooks is called a process. A process is just a program that's actually running. So it's not the icon for the program sitting on your desktop. It's the living, breathing, active version of that program after you've clicked on it. It's the absolute basic unit of work that the operating system has to worry about. So every cook, every process gets its own personal workstation with everything it needs. You've got the recipe, which is the code. You've got the ingredients, that's the data section. And they have a little notepad for scribbling down temporary measurements. That's called the stack. But the single most important thing at their station is the master recipe card.
And that is the process control block, or PCB. Seriously, think of this as the most critical index card in the entire kitchen. It tells the general manager everything about that cook's dish, who they are, exactly what step they're on, and what they need next. Without this PCB, the OS would be totally, completely lost.
Right, so just like a dish being made in our kitchen, every single process goes through a really clear life cycle. It doesn't just pop into existence and start working. No, it follows a very specific path from the moment it's created to the moment it's finished.
So let's trace its journey. First, a process is new. That's the order coming into the kitchen. Then it gets to ready. All the ingredients are chopped, the cook has their apron on, they're just waiting for the head chef to give them the nod. Running is when the head chef is right there, actively chopping and stirring their dish. Waiting is, well, maybe the dish is in the oven, the cook can't do anything, they're just waiting for a timer to go off or for a file to finish downloading. And finally, terminate. The dish is plated, served, and the job is totally done.
Okay, this is where it gets really interesting. We've got all these cooks, all these processes, ready and eager to work. But here's the fundamental problem, the big challenge that this whole system is built to solve. Our amazing kitchen, it has a major bottleneck.
We might have hundreds of cooks all wanting to get their dish made, but we only have one head chef, the CPU. Now, a single CPU core can, at its heart, only do one thing at a time. So how in the world do we create that feeling that all these dishes are being cooked at once?
The answer is a little piece of magic called a context switch. This is the OS's real superpower. The head chef works on one dish for a millisecond. Then the general manager yells, "Switch!" The chef instantly saves all their progress on that dish's recipe card, the PCB, grabs another cook's card, gets up to speed in a flash, and starts working on that dish instead. And this happens thousands, even millions of times a second. But, and this is a huge but, there's a catch. During that tiny moment of switching, when the chef is putting down one recipe card and picking up another, no actual cooking is happening. It's pure overhead. It's a cost of doing business. And the main goal of the OS is to make that switch so fast it's almost instantaneous. So who's making all these calls? Who's the one telling the incredibly busy head chef which cook gets their attention next? Well, that crucial job belongs to a special management team inside the OS, and they're known as the schedulers. And there are basically three managers on this team. You've got the long-term scheduler. He's like the bouncer at the front door. He decides which new jobs are even allowed to come into this chaotic kitchen. Then you have the short-term scheduler. This is the expediter, the one shouting which cook gets the head chef right this second. And then there's a medium-term scheduler who can basically tell a cook to go on a break if the kitchen just gets way too crowded. And you can see right here how their jobs dictate their speed. The long-term scheduler is slow, kind of chill, making a decision every few seconds or so, but the short-term scheduler, It has to be unbelievably fast, making decisions in tiny fractions of a second as it directs the head chef from one task to the next.
So how do these schedulers, especially that super fast short-term scheduler, actually decide who goes next? It's not random. They follow very specific strategies or algorithms, and each strategy creates a totally different vibe in the kitchen.
The most basic rule is called first come, first served. And it is exactly what it sounds like. Whichever cook lines up first gets the head chef's attention first. It's simple, it feels fair, just like taking a number at a deli counter. But it has a huge potential problem.
Sure, it's easy to set up, but imagine the first person in that deli line wants to order 200 custom sandwiches. Everybody else behind them, even the people who just want one bag of chips, has to wait forever. In computing, we call this starvation, and it's when one big, long job makes the entire system feel sluggish and unresponsive for everyone else.
Because of that, a way more popular approach is called round robin. In this kitchen, every single cook waiting in the ready line is guaranteed a small slice of the head chef's time, maybe just 10 milliseconds. We call this a time quantum. Once their time is up, they go to the back of the line, and the next cook gets their turn. It's designed to be incredibly fair.
And the whole game here is finding the perfect balance. Round robin is great because it prevents any one cook from hogging all the time, which makes the whole system feel really responsive. But picking that time quantum is absolutely critical. If it's too long, it just turns into that slow first-come, first-served system again. But if it's too short, the head chef ends up spending more time switching between recipes than actually cooking anything. It's a real balancing act.
So, we've met the cooks, the head chef, and the whole management team that's running this insanely complex kitchen. Now let's just step back and tie it all together and see how this amazing, invisible dance creates the experience you have with your computer every single day.
Every single time you move your mouse smoothly across the screen while a 4K video is playing and a huge file is downloading in the background, you are witnessing the result of this perfectly choreographed ballet. Those lightning-fast context switches and the intelligent scheduling rules we've been talking about, that's the hidden engine that makes modern multitasking feel so completely effortless. And really, it all boils down to this. The true genius of a modern operating system isn't just about its raw power to crunch numbers. It's about its sophisticated, elegant, and incredibly fast ability to juggle, to prioritize, and to decide what is the most important thing to do in the very next millisecond.
So I'll leave you with this question to think about. For your own computer, what do you think is more important? A super fair system like round robin that gives every little background task an equal shot? Or would you rather have a more complex system that might slow some things down, just to make absolutely sure your video game or your video call never, ever stutters? It's a trade-off that the people who design these systems wrestle with every single day.